Assalamualaikum and very good day. My name is Muhammad Alif Asraf bin Majuraini from the MMP section 101. Today I will present my bachelor degree project 2, which is effect of T6 heat treatment on microstructure properties of graphene composite. Before I start my presentation, I would like to introduce my supervisor, TS Zulkarnain bin Majo. In introduction, I would like to give some brief and highlight important things related in my research. First is, MMC has recently become a hot topic of research because to their height-specific strength, low cost and good wear resistant. Analysis in aluminium metal matrix composite has enhanced considerably due to their height-specific strength, low cost and high wear. The last thing is, graphene is the thinnest material notable at 1 atom thick, stronger than steel despite its excellent conductor of heat and electricity, and has fascinating light absorption abilities. Problem statement that can be obtained from the study is lack of study of parameter on stochastic with graphene as a reinforcement in LMC's aluminum alloy to get to achieve consistent graphene dispersion in molten aluminum alloy during stochastic. There are three objectives in this research. First is reinforce the graphene and magnesium in the LMC aluminum through stochastic process. Second objective is to find the effect of different parameters in stochastic such as stir time and GNP, and lastly is heat treatment. The last objective is to examine the microstructure of the graphene, enhance the aluminum LMC. A major influence on the precipitation reaction sequence and kinetic during the artificial aging process at high temperature is exerted by the natural aging process at normal temperature that occurs after the solution heat treatment and quenching. This is represented in the mechanical tensile quality of the cast component, notably in the yield strength and illumination of the component, based on Liu 2009. MMC made using the stir casting method are very affordable as compared to other methods of manufacturing. As previously stated by Sharma et al. 2020, the fundamental purpose of the stir casting is to generate a suitable degree of moisture in the casting. For methodology, the first process is to obtain the raw material. Material used in this study is aluminium, graphene and magnesium as a composite. Magnesium carry the graphene powder inside the molten aluminium, also to avoid the graphene splitting away and to avoid the graphene float. The next process is stir casting. Potable furnace was set to 700 degrees Celsius to melt the aluminium. Then it will plunge the magnesium and graphene when the temperature lowered to 655 degrees Celsius. Then it will be stirred for a few minutes according to the parameter. The molten aluminium will be poured into the billet. In heat treatment, there are two types in this research, which is short heat treatment and standard heat treatment. The difference between these two is the first phase heat treatment. Short heat treatment will be heat until 540 degrees Celsius for 3 hours, while standard heat treatment for 8 hours before it quenches. The second phase, short heat treatment and standard heat treatment will be aging to 180 degrees Celsius for 3 hours and then cool it in room temperature. For fabrication process, the billet will be sectioned into a few pieces. The most important factor is to produce a section that is free from burning, distortion and deformation, with the least amount of surface reaction. The next process is grinding the sample to remove burr and to obtain smooth surface. Polishing will make the material more reflective and smoother. It will go through a few processes before etching the sample. The last step is to analyze the microscope using the optical microscopy. Software used in this research is Isolation DT. The Isolation DT software was used with a nickel optical microscope at 1000 magnification. The software then calculates all different types of grain size on the left and right. After that, export the data to an Excel spreadsheet. On the mean area graph, we can see sample 4 and sample 6 has the least mean area, which is 11.58 micron and 8.86 micron respectively. By addition GPN and stir time for 7 minutes, sample 6 grain size is reduced by 58.27%, while sample 4 is reduced by 45.45%. The change in reduced size of grain related to the change of mechanical properties. On the right graph, referring research on Adidas Nicholas et al. 2012 stated larger grain size indicate weaker refinement, whereas smaller grain size indicate more strong refinement. From that, we conclude that sample 6 has the best parameter among the other sample with 0.3 GNP weight percentage, 7 minutes stir time and treated with short heat treatment. By employing stochastic, this article provides the result of an experimental study on the effect of T6 heat treatment on the microstructural properties of all-graphene composite. There are a variety of inferences that might be drawn. First is, heat treatment is required for the sample that has already been modified by the addition of graphene and magnesium in order to increase its mechanical properties even further. Second is stirring time is significant process parameter in stochastic process. Lower stirring time may lead to clustering of particle reinforcement and result non-homogeneous distribution of reinforcement particle. And lastly, from observation, different parameters give a various result for each sample. Sample 6 has a better parameter compared to the other sample with short heat treatment, stir time 7 minutes and 0.3 GNP weight percentage. There are a few recommendations in this research. First is increase amount of graphene and magnesium. This is in order to ensure that the graphene and magnesium are evenly disseminated throughout the aluminium. Second is bigger the steering blade in order to truly mix the piece of magnesium wrap and graphene together. The third one is applying scanning electron microscope SEM and EDX spectroscopy. This is to get better understanding in microstructure. These two can get many details compared to optical microscope. Lastly is using cooling slope during the pouring process in casting. When compared to the cooling slope cast sample, the conventional stir cast composite has completely dendritic microstructure, while the cooling slope cast sample has an aqueous morphology. That's all from me. Thank you.